refraction? Refraction is the change in direction of light as it passes across the boundary separating two media caused by its change in speed. In the previous part of this lesson, we saw what refraction of light is. It's simply the bending of light when it travels from one medium to another. The question I left you with was, why does light change its direction after entering another medium at an angle? Let's discuss that in detail. The change in direction of light occurs because of the change in the speed of light in that medium. When light enters another medium, there is a change in its speed. The speed may either increase or decrease depending on the medium. Note that when we say that the speed will increase, it does not mean that the speed will be greater than this value, which is the speed of light in vacuum. When the light is entering into the glass at an angle, it travels at a lesser speed than in air, and when it goes from glass to air, its speed increases. So it's because of this change in speed that the direction of light changes. But what if the light is entering perpendicular to the surface of the glass? Will its speed change? Yes, its speed will change, however, it does not bend this time. Yes, the refracted ray propagates in the same direction as the incident ray. Talking about the case when light enters at an angle, there is one more observation that we can make. Observe this part of the refraction. Observe the incident and refracted rays. We notice that the refracted ray is more towards the normal than the incident ray. When the light rays enter the glass from air, it bends, and it bends towards the normal. And from this refraction, we can see that when the light ray again enters the air, it bends away from the normal. So we can say that when the light travels from an optically rarer medium to an optically denser medium, it bends towards the normal. And when the light travels from an optically denser medium to an optically rarer medium, it bends away from the normal. What do we mean by optically rarer and denser mediums, by the way? An optical medium is a medium through which light can propagate. Since both air and glass are transparent, light can pass through them. So, both of them are optical mediums. What about rarer and denser? If the refractive medium is optically rarer compared to the incident medium, then the speed of light in it will be greater. And when the refractive medium is optically denser compared to the incident medium, the speed of light in it will be lesser. Note that in both cases, we are comparing the speed of light with the speed of light in the incident medium. So what do we understand by this? How can we summarize it? When light is traveling from an optically rarer medium to an optically denser medium, its speed will decrease and it will bend towards the normal. Whereas, when the light is traveling from an optically denser medium to an optically rarer medium, its speed will increase and it will bend away from the normal. Now that this is clear, I want you to understand another concept. Now, instead of a glass slab, we have water, and also suppose that the ray of light is incident in the same direction. We can see that this angle is the same in both the cases. So will the refracted ray in this case travel in this direction only? In other words, will the angle of refraction be the same in both cases? No, the angle of refraction will be different in this case. In fact, the angle of refraction here is greater than the previous one. So what can we infer? We can say that the refraction of a light ray depends on the material medium on which light is incident. Yes, light rays will be refracted by different amounts in different materials. But wait, I have a couple of questions for you. Talking about the case when light enters at an angle, how does the change in speed result in the change in direction of light? And why does this perpendicular ray not change its direction after refraction? I know you must be curious to know the answers. However, we'll understand this in the next video. It's really interesting. Make sure you watch it. the point of incidence all lie in the same plane. It means that if I were to draw this on a piece of paper, they all will be on the plane of paper and not out of the paper. What about the second law? The second law is also called Snell's law of refraction. Snell's law gives us the relation between the incident and refraction angles and the refractive indices of the mediums. What is the
refraction of light through a rectangular glass slab? Learn to draw the label diagram showing refraction of light through a rectangular glass slab. In the middle of the sheet, draw a rectangle ABCD. Shape the rectangle and label it as glass slab. Label the lower part of AB near corner B as glass. Label the upper part of AB near corner B as air. Also, label the portion to the right of BD near corner D as air. From the top left corner of the sheet, draw a slanting line to meet AB. Label the point where this line meets AB as O in uppercase. Draw an arrowhead on this line pointing towards O. Put two small dots on this line above the arrowhead and label them as E and F, both in uppercase. This line represents the direction of the incident ray. Now extend the line beyond O by a dotted line to cross the side CD. Label the endpoint of this dotted line as P in uppercase. From the upper part of AB, draw a straight dotted line perpendicular to AB that crosses the point O like this. Label the upper end of this dotted line as N and the lower end as N dash, both in uppercase. After that, between the line segments FO and NO, draw an arc to indicate the angle of incidence at the first surface and label it as I1. From O and to the right of O and dash, draw a slanting line to meet CD at a point to the left of the dotted line OP. Label the point where the line meets CD as O dash in uppercase. Draw an arrowhead on OO dash pointing towards O dash. Now between the line segments ON dash and OO dash, draw an arc to indicate the angle of refraction at the first surface and label it as R1. From the upper part of CD, draw a straight dotted line perpendicular to CD that crosses the point O dash like this. Label the upper end of this dotted line as M and the lower end as M dash, both in uppercase. Again between the line segments OO dash and MO dash, draw an arc to indicate the angle of incidence at the second surface and label it as I2. From O dash, draw a slanting line parallel to OP like this. Put two dots on this line and label them as G and H, both in uppercase. Below the point H on this line, draw an arrowhead pointing downwards. Between the line segments O-G and O-M-, draw an arc to indicate the angle of refraction at the second surface and label it as R2. From O', draw a straight dotted line perpendicular to OP. Label the point where the line meets OP as L in uppercase and you are done. Here is the label diagram showing refraction of light through a rectangular glass slab.
Smart learning for all.
Topic: refraction of light.
Huh?
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out.
Oh.
Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. But do you know why your magic wand appeared bent in water?
Oh.
It is because of refraction of light. Refraction of light is the change in direction of light when it passes from one medium to another obliquely. So, what do you think are the two media here? You don't know? No worries. I will tell you. They are air and water.
Oh.
When the light rays coming from the tip of the magic wand pass from water to air, they change their direction, that is, they get refracted. When these refracted rays reach our eyes trace them backward as straight lines. Due to this, the rays appear to come from a point slightly above the original position. Hence, the magic wand appears to be bent in water.
Oh.
Similarly, like the magic wand, a pencil appears to be bent in water.